Hello and welcome to my video, lesson 1.3 on the volume capacity of prisms and cylinders. So first we're going to just mention that the methodology is always going to be the same when it comes to volume of these types of things. A sphere is different, but when it has one flat side and it's the same all the way throughout, then you can use this methodology. And that's finding the area of one side and multiplying it by the height or the length, however you want to look at it, the opposite direction or perpendicular to whatever that side that you found. Okay, so in the case of the rectangular prism, the area of a rectangle is length times width. So all we have to do is we need to have volume equals the length times width, like I said before, but times the last dimension, which is height. So in this case, length is 5 times width is 2 times height is 3. So if we multiply those together, we have 6, we have 5, we've got 30 centimeters cubed. So all we do is multiply length times width times height. But you can sort of think about it as the area of the one side times by the other direction. So the area of this one side times by the perpendicular direction, right? So that's one way of thinking about it. Actually, I'll keep that shaded in. It'll give you an idea when we get to this next one. Okay, so that now we're looking at a triangular prism, and so what we have here is with a triangle on one side. So the area of a triangle is base times height divided by 2. So just a reminder, so it's just half of a rectangle, so that's why it's divided by 2. So anyways, so what we're telling you right now is that volume of a triangular prism is going to be base times height divided by 2, and then multiplied by the other side, which in this case is our length. So that's just as a aside. Whoops, why is that happening to me? Just so you guys can visualize the side that we are finding the area of. Right? It's this side here, or the front side, but I don't want to cover up the information that we have so far. So we find the area of the triangle, and then we multiply it by the rest of the side. So if we do that in this case, base times height is, sorry for that, keeps happening, 6 times 4 divided by 2, and the length is 8. So let's calculate that out. 6 times 4 is 24, divided by 2 is 12, times by 8. 12 times 8 is 80, 96. So 96 centimeters cubed. Alright, so now we're going to try to do the same thing again. So the first one we found the area of the rectangle, then multiplied it. Second one we found the area of the triangle, then multiplied it. And last but certainly not least, we are going to find the area of the circle and then multiply it. So the area of the circle and then multiply it. So according to our strategy that we just mentioned, we're going to find the area of the circle and then multiply it by the leftover direction, or the perpendicular direction, which is the height. And this has lowercase h, so let's just keep it the same. So pi r squared, well, pi is just pi. R is, in this case, 2, and h is 8. So 2 times 2 is 4. 4 times 8 is 32 pi. And if we find that as a numerical value, we get 100. Oh wow, that's almost dead on 100. 100.5. So we, if we want to, we can round up to 101 centimeters cubed. So the only thing to add on to this, to mention, is that you could have multiple shapes attached to each other that you just added. So if I was asking about the volume of all three shapes combined, literally all you do is you add this number, you add this number, and you add this number. So that if you have, let's say, a rectangle that's attached to another smaller rectangle, guess what? That's how you're going to go about it. Let's put it on this side here. Smaller, flatter rectangle. So, I mean, you just find the volume of the one shape in here, then you'd find the volume of the other shape in here, and then you'd add them together. So that's all there is to volume of prisms and cylinders. I hope this video helps you understand that a little bit better, and good luck.